Okay, so you probably read the question already. Here's a drawing of what's going on. Here's where the balloon is. Here's where the bicyclist is after some point in time. Okay, so the balloon is up here. The bike's over here. There's three variables that are going to relate to each other. There is the height of the balloon, which I'll call h. There is this horizontal distance, which, man, what can I use for a letter there? We'll call that A, because I've already used h. So this represents the horizontal distance from the balloon to the bicyclist. And then there's this diagonal distance, d. Those things relate to each other. The question they're asking about is how fast is the distance between the bicyclist and the balloon increasing? They want to know something about this. How fast is that diagonal distance changing? They want to know d prime. We don't have a d prime right now. I mean, we could relate these to each other using Pythagorean theorem, but it doesn't tell us what d prime is. So that's where calculus comes in. You can differentiate this with respect to time, which needs implicit differentiation, right? When I take the derivative of this with respect to s, I don't know what h equals with respect to s. I can't do my power rule and all that stuff because there's no s in the function h. So I need, when I use the power rule, the 2 comes down and multiplies, but then the derivative of the innermost function is unknown, so we have to leave it as h prime. And here, this is 2d times d prime. Now we have a d prime to solve for. We just need some numbers to plug in here. And that's what they give us up here. They give us enough information. The height is rising at a rate of 5 meters per second. So the rate of change of the height is 5 meters per second. The bicyclist is traveling horizontally at 10 meters per second. So we know what a prime is. That's good. If we were to plug that in, though, we have too many other unknowns. We need to have numbers for everything else. We need an h, we need an a, we need a d. The height starts at 50 meters. They're wondering what is d prime 2 seconds later. So if I'm traveling at a constant rate of 5 meters per second up, 5 meters, 10 meters, I've gone 10 meters above. So now my height is going to be 60. Because it's been 2 seconds. I've traveled 10 meters up into the sky. So I'm not just 50 meters above the ground. Now I'm 60 meters above the ground. And then what's this distance? After 2 seconds after passing directly underneath the balloon, I'm traveling at 10 meters per second. So this is 20. And then this diagonal distance, now that I know h and a, I can find out the diagonal distance by using a squared plus b squared equals c squared. I get 60 squared plus 20 squared equals d squared. So 60 squared is 3,600. It's 400. So we got 4,000 equals d squared. Square root both sides. And then we can simplify that. When you simplify a radical, you always want to try to pull out something that you can take the square root of evenly, not 1,000, right? You'd think after many years of teaching math, I'd just know that, but how about at least 100? Look, this is the same thing, because 40 times 100 makes 4,000, and I know what the square root of 100 is, 10. And then I can simplify some more. I can pull out another perfect square root, right? Because 4 times 10 makes 40, and I pulled out a 4 because I also know that that's 2. So 10 times 2 makes 20. So if you had trouble with that, you'll want to go back and review, like do a YouTube search for simplifying radicals. Okay. So I just found out what d is. It's 20 square root of 10. Now I have everything I need. I'll plug that in before I forget it. To h, our h is 60. H prime is 5. Our a is 20. And our a prime is a constant 10. So you just have to solve this equation for d prime and you'll have your final answer. So you can try to do that real quick. That's 600. That's 400. And then this is 40 square root of 10. times d prime. We got 1,000. You want to take 1,000, divide 40 square roots of 10 from both sides. So 1,000 divided by 40. Oops, 100. 25. So this is 25 over the square root of 10 equals d prime. We could rationalize the denominator, but I think that's probably fine.